Hello, everybody. Welcome to the Melb.net inaugural event. Welcome to the Melb.net inaugural event. Tonight, I'm going to have a chat with you about Blazor web apps. Now, feel free to ask questions throughout the talk. It's about 45 to an hour. Because if you have to leave your questions right till the end, you might forget about them. So just use the chat or raise your hand, and I think Jonathan will relay the question. So, as a .NET developer, for me, there's a fair bit of pain when it comes to setting up a new project. If, for instance, learning Angular, it's got a fairly steep learning curve, and it's super opinionated. So if you want to do something that doesn't quite fit with the framework, it just says, no, you can't do it. React, on the other hand, it's a little bit better. It's a lot more flexible. You can do a lot more stuff in it, but to build a full app, you have to bring in a whole bunch of third-party dependencies. Vue, for some people, they say it's perfect. It can do everything, but I haven't played with Vue yet, but maybe one day I'll give it a go. But one of the other things is I find that these JavaScript frameworks, they rust pretty quickly. So by the time I've done my first NPM install and production build, well, it's time to update everything again. So I don't quite like that. It's a little bit annoying. And JavaScript itself, it's dominated web development for best part of about 25 years. And sometimes it just feels like you're dealing with pure anarchy. It's a great language. You can do a lot of stuff, but you can also do some really crazy stuff, and it just doesn't sit well with some .NET developers. We do have TypeScript, makes things a whole lot better. We get static types as well, but you can still get away with doing some crazy JavaScript stuff. And some people, they're not comfortable with that. When they see it, they don't quite get it. But the other thing is, when it comes to stitching together a .NET API with the JavaScript framework UI, there's a lot of duct tape in the middle you have to do to translate your C# models into TypeScript interfaces and so forth. And doing it by hand, it's absolutely painful. There are some generators out there that make it a lot easier, but there's a lot of sort of things that can go wrong in that translation as well. There should be a better way. And also, when it comes to debugging our applications, it's a bit annoying sometimes. If you want to debug a full stack, you have to jump between the browser and VS or VS Code. You can sometimes do everything, say, with an Angular or React application. Most of it can be done in VS Code itself, but not everyone uses that. So I prefer Visual Studio most of the time. So you have to jump between tools to get things done. That's also a little bit annoying. So hopefully there is a better way. A little bit about myself. My name is William Liebenberg. I'm a solution architect at SSW. You can find me on Twitter. I have a blog site called Azure Gems, and you can also find me on LinkedIn to engage a little bit more formally. I started programming when I was about 5 years old, using BASIC on a Spectrum Video 328. It looked like this, nice and beige, and had a whopping 8 kilobytes of memory. And apparently for some people back then, that was quite a lot. But compared to today's standards, it's very little. It's long before CD-ROMs and the internet. So that's what we had. And this sort of even dummied as my sort of like my Xbox. You could load games from cassette tapes, which basically they don't exist anymore either. But yeah, it's a lot of fun, and that's where I went and fell in love with programming. Then many years later, I started developing professionally with C++ in 2004. And this is when IDEs were pretty much very low res compared to today. A lot of fond memories doing the sort of MFC and Windows programming back then. Then finally, I moved over to .NET version 2 in 2006. I skipped version 1 and I thought, oh, what's this crazy new technology? It won't last, but hey, it's here today still. We've got .NET Core, and .NET 5 is just around the corner. So I was wrong, but luckily we started with version 2 and been doing it, loving it ever since. Then Azure as well. I started developing enterprise app software with Azure since 2014, and pretty much every day I do something in Azure. So there's a lot in there. There's something for everyone. So if you haven't tried it out yet, it's definitely worth giving a shot. So just for today's agenda, I'm going to show you how to build a Blazor web app in 5 minutes. We'll go through what you get out of the box, and then look at why you need to use Blazor WebAssembly. And when you're talking about Blazor and enterprise, you can pretty much never sort of sidestep talking about clean architecture. So we'll look at how we can take Blazor application and what architecture we can look at to put it out in the enterprise. And then finally, just taking our Blazor web app that we're going to make today and running that in the cloud. So with Visual Studio, very easy. You can just go File, New Project, and select the Blazor application. But to sort of taunt the front-end developers that all love VS Code, I'm going to just go and use VS Code to spin up a new Blazor WebAssembly application. So here we go. So just go to .NET, new, Blazor WASM. So WASM is short for WebAssembly. I'll just give this a name. I'm going to call this Blazor Melb Net. Ooh. Oh, what? Oh, that is a typo. There we go. .NET new. And so this is going to restore a few things for us and ready to go. So just going to change into my Blazor Melb Net folder and I'm going to start VS Code. And of course, it always opens on the wrong screen. So let's bring that over. So what do we get? Well, like all good programs, we start with program.cs, and there's a main method. It's very short. It's only 4 lines of code. Very similar to like an ASP.NET application. We've got a web host builder, and we see here we're adding a root component called app, and it's looking for this app tag, which I'll get to shortly. But here's something very familiar. Let me just make this a little bit bigger. All right. So something very familiar. So dependency injection. We are adding in a new HTTP client, and this one's just pointing to our base address. This can be anything you want to point to your a real backend. Doesn't have to be a .NET backend. It can be Node.js, whatever you want. Doesn't matter. And it simply just starts running the application. Yeah, very familiar. We've got a project CS. I'm actually running .NET 5 Preview 8, so leading edge of technology, and it's working quite well. So fingers crossed tonight, everything goes to plan. If you're using the .NET 3.1 version, it looks slightly different, but not much. We start with the app.razor file, and this is where sort of the crux of everything gets rendered through here. If there's a route in the application that is found, we use this route view, and it uses a default layout to display our application. It's very similar to how React and the Angular routers work, if you've used those before. But for, say, a route that has not been found, it will redirect us to just a simple error page. If you go and add a whole bunch of other cross-cutting concerns to your application, whether they're online or offline, authorized, unauthorized, all of that will be built into this app.razor file. And here's an interesting one, the underscore imports.razor. So this is like a global include file. You can use a using statement to bring in component libraries or any other sort of tools, .NET libraries that you want to use, without then having to add this using statement to each of your Razor view files. So it's just a nice little shorthand. Here is a very familiar www-root folder, and we have an index.html. And this is, when we navigate to our application, this is where the application is going to kick off. We see here's that app tag or the app selector we saw in the main file. So very basic, just a bit of text. But once that Blazor application is spun up and it's going to start running, it'll replace all this with our real Razor components. And what makes all of this possible is that we bring it in the blazor.webassembly JavaScript file. And this is what allows us to run real .NET libraries, C# code in the browser. WebAssembly, yeah, it's really cool. And I'll go through some more of the details shortly. We have a shared folder. There's quite a few things in here. So we've got Razor files with some markup here, CSS files for styling. And we're going to look at this nav menu a few times during the talk tonight. And we'll be adding a bit more code to this. So this is where we're going to add some routes to our components. For instance, we've got a counter, and it's an example for fetching data from an API. And what that looks like, for instance, here's some Razor components. Very simple. Some markup. We have some real code here, C# code. So you can see it all looks very nice and familiar. And what I'm going to do, I'm just going to quickly start up the .NET Watch run. So this should build our application, watch for changes, and as we type and modify the code, it should rebuild it for me. All right, here it is. Okay, there's a Blazor app. Woohoo! Let's zoom some more. And go through. Here's a little counter component. Click me, increments the count. Go to fetch data, and it's a grid. It shows some information. Pretty cool. So you notice here, I'll go back to my counter. The number resets. And I'll cover why that happens. So this is all got to do with state management. But let's look at some more interesting stuff. I'm going to open up DevTools. And there's a zoom screen on my screen. I don't think you guys can see it, but I can't click stuff. There we go. All right, so look at the sources here. You see our counter component, that's what we're on. But more interestingly, I'm just going to reload this. And we see here is the Blazor WebAssembly file and sort of all JavaScript. But this is not everything that we need to look at. What I'm looking for is in the console. You can see here it says that there's a debugging hotkey, Shift-Alt-D. You can see Blazor loaded 9 megs with the resources already. That sounds crazy. Very simple application. But if we look at what's there, you can see some Microsoft ASP.NET Core, authorization, dependency injection, logging, there's all sorts of stuff that we're very familiar with. Diagnostics, drawing.dll. Wow, whole lot of stuff. You can see the size of everything here. But right down the bottom, around about here. So the .NET.WebAssembly runtime. So this is the preview version, so it's a bit bigger than it normally is. The current 3.2 release is about 700 kilobytes. This is a bit bigger, but hopefully by .NET 5, the final version, this has all been shaved down a bit more. You can see a whole lot of DLLs, and we can actually use all of that in our code. Now let's just try out something really cool. I'm going to open up this debugging hotkey. So it should spin up a window, and it says, hey, I can't debug this tab. Now that's because Chrome hasn't, or Edge hasn't been enabled to do a remote debugging session, but it gives us a tip. So I'm going to grab this one here, this little line, and Windows plus R. Bring that over, paste that in, and that will, again, on the wrong screen, open up another instance of Edge. So important not to close the one behind it, because then it'll stop everything. And it's exactly the same application again. So if you open up the DevTools again, zoom in some more, and look at something very interesting. Let's do that again. Not F12, very important, not F12, the hotkey, Shift-Alt-D. So we get a second tab for DevTools. So it's a little bit different than what we're used to, but pretty cool. So we get this sort of nice rendered view, but I'm not interested in seeing that right now. So it's called the screencast. I'm going to just hide that for now. What I'm interested in is looking at sources. If we navigate here, we're actually seeing, get rid of that, go away. Why is everything, there we go. All right, so now we can actually see real C# code in the browser. Look at here, all our components are here. Here's the counter, for instance. And if I set a breakpoint here, hey, it stops here, cool. I can see the current value of current count is 0. If I step over one line, now it's 1. And awesome. So we're actually debugging C# code in the browser. Woo! Very cool. Now, we can also debug in Visual Studio Code at the same time as well. So it all actually works quite nicely. So if I'm just going to go and resume, I'll go back to VS Code. Same thing, if I just put a breakpoint here, and it's usually a good sign if it's a bright red, then it should just work. If I press F5, it's already attached. And let's press a button. Oh, I missed a window. 1 second. Start that again. Okay, bring back my window. Oh, I've lost the window. Oh dear. Let's start the one again. F5 in VS Code, choose Blazor WebAssembly. Here it is. I'll enable the, okay, why is it doing that to me? So tip, this might be because of the latest .NET preview. Let's just see if I can stop that first one I'm running. And I'll do something a bit different. I'll just get it to build instead of running. Okay, I can run it out of VS Code. Okay. Give us one more go and then might move on. And yes, should have been running by now. I'm not sure what has gone wrong, but it happens. All right, we'll get back to this shortly and we'll sort it out. Quick stop. And I'll just close that. All right. So back to the slides. Just to recap, we have a program CS, just like every other .NET program, where everything starts up. We set up our services and kick off the program. The index.html, very important. We can put on all our styling and other JavaScript libraries you want to load in, and it has to include the Blazor WebAssembly framework. App.razor is the sort of main rendering page for our application, and a few other cross-cutting concerns into that as well. We've got a global include file. And actually, there's with the underscore imports .razor file, you can include one of those in each component folder. So sort of just scope to that folder alone. So you can sort of have a bunch of mini ones to organize things a bit better. The main layout, I actually skipped over that one, but that's sort of the where we have a layout for our application, and it's got an app body render fragment tag that renders all the content inside that main view of ours. We'll see that again shortly anyways. The www root folder for all our static content, images, CSS, fonts, etc. And of course, our own C# and Razor files. So now we know how to make a Blazor web app in 5 minutes and debug it. And I promise you the VS Code debugging does work. Just not sure what I did wrong. Figure out later. Why you need to use Blazor WebAssembly? I'll just give you one very good reason. And that is because we can run C# code in the browser. For me, that's very exciting. And as we'll see, there's quite a lot of cool benefits we can get with being able to do this. I'll give you a few other reasons. We get a full .NET SPA-based framework, or .NET-based SPA framework. And it's very exciting because we can have now a full .NET stack. You've got full JavaScript stack, but that's Node.js and Angular or React, etc. Now we can have Blazor and a .NET Web API stack. It's great. It's all very familiar, nice and easy tools for us to use. What is very cool is we can have shared libraries between our client and server applications. So we don't have to translate from one language into another. We just take the same code that we wrote for the server. We can reuse some of that in the client, and it's super easy. And as we'll see later, we can actually bring in existing .NET NuGet packages. So even stuff that was written before Blazor, we can bring in and use that in the browser. It's really cool. Now, Blazor is not Silverlight. A lot of people have asked me this and sort of making comments about it's like Silverlight. It's completely not the case. Silverlight was just a browser plugin. Blazor, it's not. You don't have to install anything to run Blazor. It just uses the WebAssembly framework, gets the .NET runtime for WebAssembly, and literally a standard .NET DLL gets that code get executed in the browser. We're also using the Razor templating engine. That's sort of something that a lot of people will be familiar with as well. So it's a lot of knowledge transfer that we can bring into using Blazor. And Microsoft is building Blazor to also be stable for many years. So next year is the LTS version, and they'll support it for us for many years and make sure it's always working and it's always up to date. So WebAssembly, it's been a standard web technology for a few years now. It's available in all the major browsers. And the difference is that it takes our code and it compiles it down to byte code, and it's sort of, when it ship it, it's just in a binary format. Compared to, say, a JavaScript library, even though we minify it, it's still text. So it just cannot actually be compacted as much as real compiled code. Another benefit is that our applications can potentially then run at near native speeds, so very close to the metal execution, which is great. So there's already some really cool benchmarks out there. It sort of shows that WebAssembly is going to change things a fair bit. We do get the same security sandbox like we do with JavaScript. So if you can't access files on a local machine, or use the Windows registry, for instance, you just can't do that with JavaScript. You can't do that with C# at all. So the V8 engine provides the JavaScript execution and it also provides WebAssembly for us. So that's the same sandbox that we get to work in. So the same limitations from JavaScript will apply to C#. But it's also, we're not limited to just C# in the browser. We can actually, WebAssembly lets us run F#, Rust, C++, and there's a lot of other languages that if they implement it, will just work in the browser. It's really cool. So which flavor of Blazor do we need to pick? Because there's actually more than one version, more than one flavor. So Blazor WebAssembly, which I showed you just a moment ago, it's client-side logic, and the DOM is updated incrementally. So that's very much the same way as how Angular, React, Vue, the other popular frameworks work. It's all done client-side. We receive the HTML and it gets rendered on the client. There's also Blazor server. Excuse me. This is different. So all the code is executed on the server. The DOM is maintained on the server, and then the changes are communicated back to the browser, back to the client, using Signal R. So all the small updates gets pinged back and forth. So all the user interactions is a sort of a Signal R message back to the server. The server reacts to that, sends a change back to the client, updates the DOM, and renders the page. So there's some cool benefits and trade-offs about this. Let's have a look. The good thing about Blazor server is there's no initial payload. It's literally just gets HTML and renders it. We saw looking at the console output before that for Blazor WebAssembly, there's a few megabytes that worth of DLLs and the runtime itself that we need to get before we can even run a Blazor WebAssembly application. So we get faster load times, and without worrying about which version of the browsers we have, it just runs on anything that you can get your hands on basically. And all of our code, all of the server-side code, it's all private. It's definitely not in the hands of the client at all. And the benefit of having a bigger security sandbox, we can do whatever we want on the server, access files, and for whatever reason, if you need to access a registry or anything else, it's all available on the server. You can do whatever you need there. It's nice and open. And yeah, but the problem is your clients, the further away they are from the server, they will then have the potential of some latency. That message has to travel backwards and forwards, sometimes in a fair distance. So even ticking a checkbox might actually feel quite laggy because it has to say, hey, server, I ticked the checkbox. Server has to re-render the DOM, send an update and apply it in the view. So you can definitely feel it sometimes. And if the connection between the server and the client drops, that Signal R connection gets short-circuited, the client application can't do anything. It's basically just, there's nothing that drives it. It's dumb. It just sits there. It's broken, basically. So you have to maintain the connection yourself. So if that drops, it's your fault. So we also have to maintain all the client state. The server actually requires more memory because it's got to maintain the DOM state for each connected client. So that hurts scalability a fair bit. And there's no offline support. So yeah, once that connection's gone, your app can't do anything. So if we compare that with the pros and cons of Blazor WebAssembly, as we said, big bonus, we can run our .NET code in the browser at near native speed. So execution should be nice and quick. We've got the shared code, makes things nice and easy. You don't have to rewrite or translate code between different languages. We don't have a dependency on any server-side technology whatsoever. Applications scale a whole lot easier, especially you can go for a complete serverless model, put it on a CDN, and make it available to everyone. And it supports PWAs. So you can actually take your app and install it on your phone, get an icon on the desktop, same thing, nice and easy. But there is the download size that we have to be concerned about for some applications. So currently it might be more suitable for a sort of internal or line of business types of applications rather than something that's going to be available to the public. As soon as people have to wait for a couple of seconds for the first thing to start rendering on the app, they get a little bit bored and maybe they won't use their application straight away. But this is improving over time. So rumors are that the .NET WebAssembly and something coming next year would actually reduce the payloads significantly. So that problem might go away. We do need a modern browser that supports WebAssembly. You've got a smaller sandbox to play in, but generally we're used to that already, so it's not a problem. And I find just the tooling for Blazor, WebAssembly, and Blazor server is not quite there yet, but it's all being worked on, so it's quite good. The big thing that's missing for a lot of front-end devs is they love the live hot reload feature, which is not available currently, but that's also coming. We're working on it. So which one would I choose? I would choose Blazor WebAssembly. It's for me still the lighter option of the two. I think being able to execute that on the client side, have it nice and snappy, for me that's a big win. So let's go and look at some actual code. Add a component. Looking at a component, we sort of break it down into a few pieces. At the top of each component file is the directives. So we'll cover a few of these, but we start off with, say, adding a page directive. We can add some using statements. We can bring in other code, component libraries or class libraries, reference them in our code in this file, and we can even inject services into a component, like the HTTP client, for instance. Then we have our markup code and Razor code. So anything HTML, you can put it all in there. You can use then sort of anything that's prefixed with an @ symbol, then is the Razor markup code. And we can use that to decide what to render, when to render, based on some logic. So similar to how React works with the JSX. You can mix your code and your markup together. And then we've got dedicated code or a logic block at the bottom, and we can add our members and methods, and we can inherit from other components and all that sort of stuff. Do all of that here in this @code block. So looking at a component, that's basically as simple as it gets. There's a heading, some simple data binding to a private string called message, and an input parameter called priority. So to use this component, you can notice at the bottom there it says myComponent.razor, and that's sort of what gives this component its name. And if you want to reuse that somewhere in the application, that's how you use it. Nice and simple. Open tag, myComponent, give it a parameter value, close tag. And that's what it's going to look like on the screen if we ran this. We also get all the lifecycle methods for components. So on initialized, set parameters, after it's rendered, we can also have some logic about should we actually re-render the page based on some asynchronous operation or something that doesn't trigger a state change for the page, but we can force that to then reload when we need to. So all the methods we need are there. It's pretty similar to on mount or ng on init that we used to with React and Angular. So a page is really just a component. So this is the same component we had before, but we gave it this @page directive at the top, and we gave it a name, so /myPage. So that's really what gives this page. You can actually, instead of reusing it as a component, you can navigate to it as a page. It'll fill your whole screen. And what's really nice is we can actually give our components more than one name. Now, this is very useful for if you had an old existing route, but you've replaced the component that can serve sort of both things that you need to do. So you can actually, instead of having a broken route, you just make it work and point it to this right component. It does come in handy sometimes. Now, some people like to take their code and split the view and the code from each other. So you can do that and call code behind. Very important, what you have to do is to always add a using statement for bringing in the ASP.NET Core Components namespace and make our class a partial class. Now, this is important to have the class name the same as the file, the razor.razor file and the .razor.cs file. So it'll take the view and the code behind and stitch it all together, and you can reuse a component. So I don't find it always to be too useful to just go down this code behind path. Only when a component gets really massive, and really complicated, maybe you want to split it up. But I haven't found it useful yet. I like it sort of the view and the code all in one file. It's nice and easy to follow. There's another way we can do code behind. So again, we have to bring in the namespace for ASP.NET Core components. We can then inherit from component base. So we can actually write like a base component type. Might add in some common features that we want all our components to have. And then all we do is to make sure that in our Razor file, we inherit the right component. And we can then add custom markup to that and use all the base functionality that we've put in. Data binding, very important. Makes things nice and useful. So in this case, just the @ symbol is a one-way data binding to a private field called title. And if we rendered that, we'll see data binding gives you wings. And we can go a little bit further. There's a two-way data binding. So for this input box, you type in some text, and if you tab away, the value in that input box is then bound to the title property in our code, and we can reuse that elsewhere. But to make it a little bit more useful, the default change event is called onChange, but we might want to reflect the change on each keystroke. So we can actually bind to the title value to based on the onInput event. Instead of onChange, we can use onInput. So we can specify this with the colon event and supply the event we want to bind on. So that gives us that two-way binding. Parameters, it's also very useful. So we can actually have the addressable components, but instead of just a name, we can give it an optional parameter on the route as well. So in this case, I've got a text value. I bind that to the text field using the parameter attribute, and then I can just use that and display that on the screen. In this case, if someone gave it no text, it would just say Blazor is awesome. If they gave it some text, then it would render that word instead. And so we can see on the onInitialize method is where we check for the null value of that text or not and assign a default value. We can also add some constraints. So instead of just everything being a text value, we can say, hey, I want this ID parameter to always be an integer. So if it's not an integer, it would actually redirect us to the error page. And here, again, same thing. We bind the ID field as a parameter, but it's guaranteed to be an integer, and we can display it and use it as an integer. Cool. But yeah, we've got a whole bunch of other types. So all the reference types available for us to use: datetime, GUIDs, booleans, decimals, floats, they're all there. So we can put those constraints in for our page routes. Handling events, so very useful, obviously. So if a component exposes some sort of behavior or event from within itself, we can expose that through a parameter. And when someone clicks on this product title printer component that I concocted up, then it'll call the clickIt method and just display a message in the console. And the way that we actually set that up inside of our component is when someone clicks on the actual button, we provide the event callback to the onClick. Now, this is probably one of the not nicest things to do in Blazor at the moment, where you have to actually give it an empty delegate to point to the onClick event callback that you invoke async with a parameter. So if you haven't done this yet, then it might take a few minutes to figure out, but you'll get used to it pretty quickly. And then, so yeah, that calls the event callback with the string input that we gave it, and then our calling component can react on that. Cool. One more thing about navigation. So we can inject a service, and that's called the navigation manager. And this is what we can then use to drive some interaction through our components. So if someone clicks on a button or a div or whatever, we can then call some code to say, hey, navigate to a particular component or page, just using the .navigate to and giving it the component name. Very important feature is dependency injection. So this is where we can set up all our service at the start of the application, that composition root, and say which API to point to, what other services we need, prepare everything so they're ready to use, and we just use them in our components. We don't have to worry about setting up, doing anything. they're ready to go. And the way we do that is just at the top of our page, we use the @inject directive, give it a type and a name, and then we can use it inside of our normal code. Nice and simple. When we're doing it with the code behind, it's slightly different. So just go back here. If you notice the @inject at the top of the file, we don't get that in a normal C# class file. We have to do it a little bit differently. There's no constructor injection. We actually have to inject it via a parameter, and we have to give it the inject attribute. And that's the only way that you can wire up the service to the code behind of a component. So very important difference. If you try and use, you can still use a constructor injection in other normal classes, but for a code behind of a component, it has to be done via the parameters. And again, we just use it as if, exactly how we're used to using it. Logging, very important for our application, so we can display some messages and track errors, etc. But the way we do it with a Blazor WebAssembly application is console.writeLine, and those messages then show up in the DevTools console. But this is pretty boring. There's definitely something a bit cooler that we can use out of the box with .NET. So in our program.cs, we can add, it's already there actually, we just add logging and set the minimum level to whatever level we want, debug, trace, verbose, etc. And inject the iLogger to our components and use it as we're used to with normal ASP.NET API. Nice and easy. But we can go one step further. We can actually use Serialog in the browser. The Serialogs existed for a long, long time, even before Blazor. So I'm going to show you how this actually works. All right. And VS Code might need to be restarted. That's all right. Let's do that again. What's the time? 7:42. Okay, no worries. What we need to do so I just need to get it to add a few things for itself in the background. That's probably why it didn't work before. Very important to click the yes button. So I'm going to add in a couple of packages. So .NET add package Serialog. And that should download that and add the reference to my CS project in a moment. Cool, that's in there. You can see here, Serialog, cool. Now I just need to add one more. So I'm going to go .NET add package. And Serialog's all about syncs. So we can bring in a pretty cool sync called browser console. Spell that, console, cool. Because this is a pre-release, I have to actually give it the version. I think I memorized that correctly. The 3, yes. Ha, works, all right. Aha, I see.
Serialog spelling.
Ah, thanks very much. Thinking, is that because I'm using .NET 5? No. Awesome. All right, we have that in there. And what we now need to do, very important, if anyone's used Serialog before, we have to quickly set it up. So I'm just going to do that real fast here in the program file, program.cs. And just need to add a username, add Serialog, awesome. And it might take a moment for it to realize that it actually is all good to go. I just have to restart the watch, build everything. Oh, that might be because of a typo. Let's fix that. Oh, looking good. All right. Now what we need to do is I'm going to add a whole new component. I want to add a whole new logging component. I'll call it logging.razor. Okay. And at the top of this, I'm going to call this logging. Okay, and then I just need to add a one using for Serialog. Now I've already got some samples here. I'm just going to bring this over real quick. What I want to do, got 3 buttons, each of them going to a different on-click handler to use Serialog to log different types of messages. All right, so save that, did that save? And rebuild. All right, let's see what happens. F5. Okay, loading's good, loading's good. Very importantly, need to actually add that to the application. So what's missing is I need to add a link to that page of ours. So I've gone to the nav menu, need to add another link here, and the href of logging, what we called our component before. Let's see, so that should be good. I think that's it. All right, so let's just go back to our application, reload. We have a logging page, 3 buttons, and what we want to see in the console is, make it a bit bigger. Oh, we have a message from Serialog in the browser with a warning and a warning and an error. Awesome, it all works. Serialog in the browser. Nice. Cool. So now Serialog, like I said, awesome. Based on syncs, just outputting to the console. Yeah, it's kind of boring, but useful in some ways. But we can actually add syncs that then send our logs to another log analytics server, or something else that we can use to analyze the behavior of our application and improve it over time, maybe fix it before the client even complains. Nicholas Blumhardt has a really cool page on there about how to actually set that up as an example. So if you can grab that link, go check it out. It's really cool. Forms and validation. I think for the sake of time, I might actually skip this demo, but we can actually do forms and bind our models to this form using strong types. We have an edit form. We say which model we want to use, give it the name of the field on our code. We can show, or say add the data annotations validator, and at the end of the component or end of the form is where we want to show the validation errors. So if there's a few inputs on the form and someone enters a name or a title that's too long or too short, it goes red and you can't hit the submit button. So we can use the data annotations to set up those sort of rules. But instead of what I would do in the demo is actually take out the data annotations validator and use fluent validation. So we can actually do that with nice looking rules instead of using attributes to annotate our models. So we can actually make our code a little bit more portable by using fluent validation as well. So that's a nice bonus. I'm going to skip that demo, but I'll make the code available for you to try out a little bit later. Now, okay, we do actually have some JavaScript incoming. It's not all just C#, right? The cool thing is we can get the best of both worlds. We can still use JavaScript in our Blazor WebAssembly applications, and sometimes we have to. We can import new NPM packages still. We can run that JavaScript. Unfortunately, at the moment, it's got to be part of the global JavaScript file. But JavaScript isolation is coming in the future. And we can actually bring in just this JavaScript runtime and say, we want to definitely call some JavaScript. And we do that just by invoking the method with a magic string to know, hey, call that JavaScript method and return me the result. We can actually do the reverse as well, where we can have JavaScript code call back into our .NET code. It's a bit more to set up than the example we have here, but it is really useful. Sometimes when we want to write a whole new fancy component, we have to do some of it in JavaScript and some of it in .NET. It does become very useful. Sweet. So now I think we want to actually make something really, really awesome. I'm going to show you how to do a very cool markdown editor in the browser with C#. So going back here, I just need to quickly go, I need a new console. And what I'm going to do, again, I'm going to bring in some old code. And one of them is called Markdig. So it's a very popular Markdown library that was written, I think, like 5 or 6 years ago. It's been around for a while, very popular. So you can get some Markdown code, put it through the pipeline, and it'll render out some HTML. But I want to add something cool. I want to add, scroll down a bit, no. I want to add in one of its extensions called markdig.syntax highlighting. All right, I think I spelled that right. Yes, very cool. And we want to get to this component, so I need to add in a link to that component. I'm just going to call that, I'll just call that Markdown. All right, so we've got a Markdown link there, so we should be able to route to that. It means we need to add a new component, markdown.razor, and inside of that, just going to put a page directive of /markdown. And what I need to do, before I can actually render anything there, I have to go to the program.cs file. And let's go away. So I need to set up the Markdig pipeline. And what I need to do, I've got the NuGet packages there. I'm going to paste this code in. I'm adding a singleton to the Markdown pipeline. Need to go and add the using. Sweet, the tools work. This is another one that's missing for the extensions for syntax highlighting. And awesome, so it's there. I'm hoping that the build has done its job. It looks good. Right. Got my link to the page in here. Now I can actually go ahead and fill in this component. So I'm going to bring in the Markdig namespace. I also want to then inject the Markdown pipeline that we set up in our project, program.cs. I'm going to call that pipeline. Oops. I want to call it pipeline. Thank you, VS Code. Then just need to add the code section. So I'm going to put a couple of things in here. Now, because we've got Serialog as well, and I know that there's one little quirk with this library. And just for the sake of time, I'm going to go straight to the last solution. What I need to do is I want to add 2 components to my screen. I want sort of one side for Markdown, some text area we can type stuff in, and I want another section where I can actually render my Markdown. And you can see here, I'm binding the text area value to a field in my code called Markdown text. I'm going to add that now. Get rid of the red squiggles. All right, so that should be there. And another one called HTML to render. Now, because of that little quirk, I'm just going to add in a slightly larger bit of code and step you through what's happening. So I'm just using a backing field for HTML to render. And so this Markdown text is what I'm giving to the pipeline. Why is it red? I'll find that in a sec. Text HTML to render. That's right.
Your pipeline is actually pipeline.
Where is that? Right at the top. Oh, thank you, Barbara. That fixes everything, almost. What's happening here? Oh, Markdig, sorry.
We do have an interesting question.
Yeah.
Can CSS be scoped? I think that.
Oh, yes. Can CSS be scoped? Yes. So that's available in the latest preview, .NET 5 Preview 8. They call it CSS Isolation. So you can actually have a markdown.razor.css file. Actually, here is an example already with the new template. So you have here a razor.css file for that nav menu component. you don't no longer have to use the global app.css with the latest preview. So yeah, for sure, you can do that. So the problem with this little library is, what did I do? Demos, you know, so Markdown's there, Markup's there. Yes. Oh, is there some new version that's changed on me? Oh dear. Oh, they have changed something. Let me see one thing. What version did we bring in here? Oh, I think that's newer than what I'm used to. Oh dear. All right, let's try one more. It should be Markdown. Yes. Something has definitely changed. Let's try that. Markdown got Markdown. Oh, there it is. I wonder why they did that. Bit different. All right. Oh, cool. Everything's rendering, building nicely. Cool. I can go back to my application on F5. We can see there's an editor here. Get rid of that. And actually, I want to show you why I have the try catch in there. So this is my text area. I'm going to render some Markdown. Oh, so it's not actually rendering Markdown. You know, like putting a heading in here. All right, that's a good reason why this is happening. Go back to our code. What we do is we're just getting this, we're binding to this HTML to render text string. And literally, we're just spitting out the HTML as text onto the screen. But how do we actually take that markup and render it on the page? Well, we've got this really cool little thing that we have to use called Markup String. And we simply take our HTML text, we cast it to Markup String. And if we go back to our application, unfortunately, we don't have live hot reload. We have to refresh. But now we go H. There we go. We've got heading, and we've got heading 2, and we can have item, and we can have what else can we have? We can have numbered lists. 2. If I can type. What we can also do, we can actually say, I want to write some C# code. You see there's some red text that showed up on the side here. There's a little bug if you have code with no code, or a code section with no code, it throws an exception. If you don't catch that, then it stops your page. Very annoying. But now we can have a cool hello world class, and we can add a method, call it wave, and can we return a emoji? If we've got wave, there it is. Cool. So we can actually have a Markdown editor in a few minutes in the browser using C# and a really old library with the latest new update. Very exciting. So very easy to use. Very, very easy to use. So you can get the code a little bit later. I'll share all of that with you. All you need to do to set up a Markdown editor, pull in the NuGet libraries, set it up in your program.cs, and go ahead and sort of use the library just to render any Markdown text to HTML. But very importantly, you need this markup string object you cast to, and that will actually take your HTML text and render it as a real markup in the view. There we go. So what else can we do with Blazor? What I didn't cover was state management. This is very important if we want to have people using our application. So one way of doing that, you can inject a state object, use normal dependency injection, and share that all around your application. But because it's all in memory, as soon as you navigate away from that page or you create a new tab, that memory is not shared. So it just goes away. You can then back that up with local or session storage if you want to maintain that state a little bit longer. And what you can also look at is the state management libraries like Blazor State, Blazor Redux, or Fluxor. Fluxor is really cool. I think it's the more purer Redux pattern for Blazor that's out there at the moment. And we're actually using this with C#9 and some cool features in C#9 that Gives us something similar to the spread operator in JavaScript and the new record type for immutable and clonable objects. Really cool. Yeah, if you look at Flux, really cool. We can also add a few other things. We can do layouts and theming, test our components. There's a lot of other companies out there that provide a bunch of component libraries, Blazor, Radson, Blazor, they're all free. The other ones, Telerik, the usual ones, they're all there, but not free. But that's cool. They're there to try out, and they're actually really good. They're all aiming to go sort of a Blazor native, so you never actually have to do any sort of JavaScript stuff in the background. Currently, there's a few things missing from Blazor that you still have to use JavaScript for, but hopefully that changes over time. We can add Webpack, so instead of just plain CSS, we can have a nice CSS processor. We can still use TypeScript if you really need to, and whatever else you want to do. Bring in your NPM packages and use that in your application. So we built a Blazor application. We saw how cool it is to use C# code in the browser, and I just quickly want to talk about Blazor in the enterprise. And I just want to do a quick time check. How much time we've got left, Barbara?
It's 8 o'clock. It's 1:08, so maybe 5 more minutes.
All right, 5 more minutes. Yeah. I can do this. Okay. Blazor in the enterprise. So Blazor's main superpower for me is the shared libraries. And the most simplest way to architect a Blazor application is like this. We have the Blazor WebAssembly application. We have our web API, and they share a bunch of code. So we can have our models in there for, if this was a blog site, we have posts, comments, users, all the other stuff that goes with it. And we can simply just deserialize. So once we send that object from the web API to the client, we just reuse the same code to read, to deserialize it. We don't have to translate or do anything crazy. It's super easy, super nice to use. But like I said, this is the simplest way we can architect a Blazor application. And for most applications, this is totally suitable. But if you want to build something that's much bigger, it's definitely, it needs to be independent of any frameworks and very little reason to change for anything. Want everything testable. It doesn't matter what UI we slap onto our application. We look at the clean architecture, and the sort of familiar layer is that all our dependencies point inwards. It gives the application very little reason to change. So this superpower of Blazor, the shared library, where does that fit into the clean architecture idea? So some people might try and add the shared library as a dependency into the application, but that's a bit of a problem because now our application is depending on something external. Just one of the rules of clean architecture. We don't want our application depending on something external, because if that changes, our application has to change, and that's definitely not desirable. We have an output dependency, so we see one of the arrows is pointing the wrong way, and if something changes, we have a fairly big blast radius. And if you want to try to deal with all of this stuff, you're sort of going to end up having some spaghetti code all over the place. It's not going to be nice to deal with. So don't do this. You might be thinking, hey, all right, I'll add a layer in between my application and presentation infrastructure. But now our infrastructure depends on a shared library. We have to add all this mapping code in between the layers. It is just unnecessary. There has to be a better way. And keeping it simple, that's the key. So far I found like all we need to do, we just want to bind the contract between our UI and the API. We don't really want to do it to the application or the core of application at all. We keep that library shared outside of the application. And yes, one of the arrows points the wrong way, but that's a conscious decision that we make because we know we want to write a shared, write some shared code between our API and a Blazor application. Now, what this might look like if we fluff it out a bit is that shared code. We could have interfaces for, let's say, very popular mediator library. So interfaces for our requests, in our case, get post, get user, and they're just interfaces. Then we go and implement them independently for the client and the server side. The client side, when it calls, sends a request for get post, the client side library will just do a web API call to the web API, which will then resolve that as a call to the database. That very same request object with a different implementation on the server side compared to the client side. Hits the database, gets the post information, and sends that all the way back to the Blazor UI. And the Blazor UI, basically, it just has a typed client that we can use. It's totally unaware that it's using Web API, and it keeps our view and everything nice and simple. So this is one way of doing it. And so far, I've been doing this as well. It's nice and simple, but we can go another step further. We can actually, just like what we used to with Angular and React, use a generated C# client. So the popular tools out there, NSwag, AutoRest, or Open API Generator, but something really cool that's coming out soon, C#9 source generators. So I've been playing around with this as well, and I think Dave's going to have a nice session on this shortly. We can actually, if I just go back a slide, the whole client and web API interaction, we can actually generate that code purposely made for our application. All the controllers, the actions, the implementation of the client-side library to call our API, we can generate all of that. And then we can just hand our Blazor application a nice DLL to use, and it's very easy. So we can then, again, if you look at the diagram, completely decouple our API and the UI. Nice and simple. If you want some more info about clean architecture, my mate Jason's got a cool .NET template. If you go to that bit.ly link, if you just want to read a few more rules about it, there's a rules to clean architecture link as well. Now, finally, just to run our application, the code, very easy. It's a static web app, and we can host that on Azure Storage or GitHub Pages. Nice and simple. It's just render the HTML, publish your application, copy it over, and it should be pretty much available to go straight away. You want to go fully serverless, you can add a CDN, get your application nice and close to all your users, and if you really need to use an API or a backend, go with Azure Functions. If you need database, use Cosmos DB. Get a nice massive scale because you're going to write awesome applications that 10,000 people a day would want to join, so you need to be able to scale. Yes, you can upload that to storage, Azure Storage real easy. I've got a link there. If you scan that QR code, you can actually get a link to an application. All the stuff I built today with a bit more, and all the source code there. So open that up, run the Blazor app in your phone or on your laptop, and yeah, go grab the code and have some fun. Just to note some things that are coming up shortly with .NET 5 in about November. CSS Isolation, which you mentioned, multi-threading in the browser, which is really cool because WebAssembly lets us run multi-threaded code in the browser. That's really awesome. So a lot of performance gains from that. Lazy loading, so we can actually have our massive applications split up into smaller pieces, so it only loads what it needs. New async disposable pattern, drag and drop, ahead of time compilation, and live hot reload was delayed till .NET 6, unfortunately, but that's going to really change the game for us a fair bit. The ahead of time compilation will shrink the size of all of our application down to very little, and very attractive option. Can't wait. So here's all the things we covered. Know how to build an application in Blazor WebAssembly, why you need to use it, how we can architect it for an enterprise type application, and how to run it in the cloud. And then in summary, Blazor is awesome. Backend C# developers can, with a little bit of HTML and CSS, call themselves full stack developers and put that on their LinkedIn. I think with the C# source generators and stuff, we're going to see some really cool architectures coming out soon. There's some really cool stuff coming for .NET 5 and 6, especially for Blazor. And this time next year, we're all going to be writing awesome Blazor applications. Thank you, everybody.